Warm greetings to everyone present here. Today I'll present a 2 month statistical analysis of food waste generated across different mess at IIT Madras that will cover the period from July 1st to August 28th. Well, the central question that we address over here is, are there statistically significant difference in daily food waste between the mess, and are there systematic temporal pattern over the past 2 months? Like, does the food statistically, significantly uh, varies across the days and everything? Well, this is not merely an operational question, it is an inference problem, right? So we had to separate the signal from noise, quantify uncertainty, and account for the data limitations. Okay, our analysis followed a classical Fisherian framework. We formulated some null hypothesis, estimated the variance component, and yeah, we'll see ahead of more what else we have done. Now I'll simply jump to the code part. Here, starting from here, we can you know, see a upward trend after July 28. This is because the students of PTech and the other people have resumed their campus life after the break. And yeah, if we see the box plot, one thing we can comment is RGC comparatively had the lowest amount of the wastage. Now we can see here the distribution is sort of skewed. Before that, we can see the mess were divided in two parts. One that were operational in full period, that is right from July 1st to August 27. Others that became functional only after 28 July. So these three were those messes. Right. Now we saw a box plot analysis as well. If you wonder why this part is light, again as I said, this is still 28th of the July, and after here as the student rise, so did the wastage. We can see there is some dark part between second and third day. Well, ideally this is Monday, Tuesday, so between Wednesday and Thursday, and on the weekend the food wastage is slightly on the higher side. Well, this is some sort of obvious about the weekend thing, but this weekday thing across Wednesday and Thursday, well, this creates a allithoric uncertainty. We really don't know about the menu of the mess. Maybe it could be because of that. Maybe it could be because of some other uncertainty. The real fact is definitely not known to us. Now, because we wanted to perform the ANOVA test, one of the important, you can say, most important condition for ANOVA is the data should follow the normality, right? So we did a normality test, that is Shapiro-Wilk test. We can see here the food waste distribution in the first month is heavily skewed, while in the later month it is somewhat, it is heavily, or you can say it follows normal distribution to a larger extent. Again, a QQ plot was also plotted that it shows it closely aligns with the line, so definitely it does follows normality. Hence, for the later part like ANOVA and other statistical analysis, the data from 29 July till the end of August was taken. Now we performed a formal one-way ANOVA and Tukey test across the mess. Our null hypothesis state that the mean daily food wastage is equal for all the mess. That is, mu of Himalaya equal to mu of RGC equal to so on to mu of P slash S. So yeah, that is what that hypothesis was. But the results that we actually observed stated something different. The F statistic was very highly significant, roughly like more than like 113. So this led us to reject the null hypothesis and implies at least one mess is different from others, right? Now, however, ANOVA tells us that not all mess are equal. It does not exactly tells us, which pair differs. So, in order to address this question, we perform 2K's HST post hoc test, that is, highest significant difference. So, sorry, honest significant difference. Mind me that, yeah. Now, it this test, controls the family-wise error rate, and a key requirement while performing multiple pairwise comparisons was that the results showed difference between high waste messes like PHS and FS. So these are the mess that are sort of high wastage leading, whereas across the low waste like RGC even after some adjustments. Now we went to one way ANOVA across the days. The F statistic was somewhat low, and yeah, this led us to the rejection of null hypothesis. The p value was almost 0.99, suggesting that no systematic day of week effect once random variation is accounted for. Now you might be thinking, rather than performing two one-way ANOVAs, why didn't we perform one two-way ANOVA? Naturally, that would have been an ideal model with factors like mess and day, and their interaction terms would have been generated. However, we lack the replication across the mess, across day cell. We need replications when it comes to two-way ANOVA. Well, in classical ANOVA terminology, we can say that interaction was confounded with the residual error when the replications are missing. Now, this definitely decreases the power of test, because if you see in the ANOVA column, there is something called as residual error. Yeah, this part. So if you see, this residual part is combination of multiple aleatoric and epistemic uncertainty across with the other errors, right? So here those uncertainties, residual error is also getting missed. Now for that reason it wasn't very suitable. So yeah, definitely our mean, what do you say, there was some estimate that some low waste like RGC will generate 140 kgs and PHS will generate 420 kgs, like 1.4 to 4.2 tons. That is something that was visible over here, right? 4 tons to 1.4 tons, that is a huge variability across the across the wastage, right? So yeah, but now because we didn't had the, what do you say, the effect of interaction, there were other things as well that limited the whole study. Let's move on to that. Non-normality in early July somewhat forced us to limit the inferential results to July 29 to August 31 itself, and lack of replication prevented us from calculating the interaction effect. Absence of per capita, like we didn't know how many students were there in a particular mess, and there could be somewhat measurement issue, though it is not very sure. So generalizability is limited to this 2 month window. Seasonal pattern or changes in student population may alter the future waste levels, is something that I feel. Well, despite this limitation, actionable analysis that this whole study yielded was over 60 days the total recorded waste was around 2.55 ton per day. Well, if we see the statistics, there are like 9,700 students in IIT Madras. Definitely not all of them might have opted for mess. The amount of waste that we are generating, if we see a data from this Food Authority Association, it says that around half a kg per serving per person is good enough, right? So the amount of food that we are wasting can almost be able to feed like 5,567 people. That is like huge. Considering the number of 9,700, not every person is eating. It is somewhat safe to say every person on an average is wasting as much food as he is eating, or like a one third of it. So yeah, that number is definitely worrisome. Right. So with this, I would like to conclude the whole thing. Thank you so much.